To tell if a molecule is polar, nonpolar, or ionic is a very important part of this class. That's why I ask you at least 5 of them just in this, and each one is worth probably a quarter point, but it does add up. And my process for doing this is, first off, if you see a molecule with only carbons and hydrogens, it will be nonpolar. And that is a rule. On the other hand, if you see a metal, like lithium is, metal ion, then it is ionic. And I guess the other fairly obvious one down here has an OH group in it. So anything that looks like water is probably related to water, and an alcohol group looks like 2/3 of water. So alcohol group. And or almost any oxygen. It's polar. Now, the best way to tell the difference between nonpolar and polar is to draw the correct Lewis structure. But anyway, that's always the best answer. Now, there are 2 that we haven't done. Here's CF4. If we were to draw the best Lewis structure for CF4, and I'm sorry, I have to draw all my dots. Now, if we were to draw this in its shape, it would be tetrahedral. And once we've got that, we could then draw dipoles in, and the dipoles would be facing the fluorines. And I believe I talked about this in the lecture outlines. It's hard to see for tetrahedral, but all 4 of these dipoles point in exactly opposite directions, and they do cancel. Ooh. Dipoles cancel. Nonpolar. Nonpolar. And finally, my last one has carbon with 3 hydrogens and a chlorine. And if you were to draw dipoles here, you would see that the dipoles do not cancel. This is a polar molecule. So we've got nonpolar, ionic, nonpolar, polar, and polar. And when you do the homework, I did my best to break them up into approximately equal portions of nonpolar, ionic, and polar, although in your everyday life, most people run into more polar molecules than the other kinds.